Hi guys, welcome to this new semester of Applied Macroeconometrics. My name is Will. I'll be your tutor here for this group. We will have a lot of connection during this semester. Just a little bit about myself. I am a graduate from the Masters of Applied Econometrics at the university. Class of 2019. I've been teaching this course, I think, for the fourth or fifth time this semester. Second time with Eric. So I'm lucky to be quite familiar with the contents. Actually, let me share my screen just 1 second. Under course help here in Blackboard, you will find this very handy consultation schedule. I am holding consultation right after the session ends, but starting next week. So please, if you guys want to check something, please come by next week. Because this week I will be, I already have another commitment, and we were instructed not to hold consultation this week by Eric. But yeah, for next week onwards, just jump into the same link, Zoom link, and I will more than gladly give you a hand with all your doubts. This semester we're going to work with R. For those of you that took introductory econometrics last semester, you are probably already familiar with it. R is a very powerful tool regarding data processing and data management. It's very useful and it's free. So it's a great thing that you guys can access, and it's a great skill to acquire in terms of what the employers are requiring out of them, all of the people that want to get into the workforce. So it's always good, right? I've also heaps of experience working with R. So yeah, I will more than gladly give you guys a hand. So the thing that you guys need to do to set up your laptops, your computers at home, is to just do a quick Google of what I did. Download R, you'll be redirected to this CRAN.R project website. In here, you will download just R as the data processing engine, right? We need to have it in our computers. If you already had it, it's just very likely that you guys have an older version. Don't worry about that. Like every version, like everything from 4 point something onwards, it's just fine. I think everything from 3.6, 3.7 is the earlier that most of the packages that we want to work are supported. So it's okay. But if you do feel like you want to be in the latest version possible, just even if you already have our studio and everything, just jump into this website, download the installer, and it will take care of the rest. It will delete the old files and it will bring everything new. So don't worry about it. The only thing is that the packages that you already have installed will be in a different folder, but it's just a matter of re-downloading. So it's okay. It will take care of the rest. And like I was mentioning, R is the data processing engine. So the one that we are, the other part actually that we're gonna use today, the other software is called RStudio. So download RStudio. You will find that here on rstudio.com, here on downloads, and you will find the desktop free version. You don't need to buy any licenses whatsoever. And it's just, it works just as fine. You can find here the driver. For those of you that work with Mac or iOS, I would recommend you to find which iOS version you're running If it's lower than 10.14, you will have to find the driver, the installer for that specific version of iOS. So yeah, it's something that I will leave up to you for your own time, for your preparation for this semester. But yeah, please, it's not it won't take much of your time, and it's a very powerful tool. Please don't just work with R, because working just this R software is quite very like user unfriendly software. So please download R Studio and we'll have something like this, right? What I would like to do is to go around. I will actually share this link for Code Share. I like to do that throughout the semester. If those of you that might took introductory econometrics with me last year are familiar with this. I always copy and paste my codes here. And for the sake of time, I will prepare a nice R script with all the codes that we're going to use, and I will share them with you through CodeShare. Okay, so it's already there for you. Please just copy, don't edit, don't type anything on this. Just grab your codes and bring it to your own workspace, please, because everyone should have access to that. I will try to do this for this semester because, well, some of the codes are very like intensive in terms of typing, and I believe we will use we will make better use of the time if we will just like I focus on the explanation of how the work is, how the syntax is, of course, and of course interpreting results. So when you guys open R Studio, if it's the first time, not like I already have here, this console window, like this panel, will be covering this whole left-hand side. So it will be something like this. Don't worry, it's completely normal, because after you open a source or like calling it informally, like a notebook in R, is when this window will also share part of the space here. So if it looks something like this, don't worry about it. I will show you how to get there. The aim of today's tutorial is just giving you a quick rundown of how R looks like how do we set up our stuff, and just run a quick importing and plotting exercises. We will not like going through any econometrics today. It's just a refresher for those of you that, or you know, an introduction for those of you that had never worked with R before. But if you guys took introductory econometrics very recently, I'm confident that you guys will be familiar with this. So if you have any questions or anything, please, by all means, just go in the chat. I always have the chat window open, and I always have an eye on it. And please just let me know, or just unmute yourselves and let me know. Alrighty. So before we go any further, you guys should be able to access. Actually, let me plug this off so you don't have all the things. Yeah, you will have the learning resources for the first 2 or 3 weeks. I'm not sure if week 3 is already filled. I think so, but not sure. I will focus on week 1. Week 1 will have a bunch of materials for tutorial 1. Blackboard changed slightly this semester. So you will get now this table of contents here. So just go to tutorial content, and I think tutorial 1, this tab here on the left, and you'll have the files that we're gonna need today. So we're gonna have a questionnaire here. This is what we're gonna work today. And we do have a couple of data sets, so please download consumption.txt and fultonfish.dat into a location that you can find easily. What I did for this semester is that on my documents folder in my laptop, I created this ECON3350 folder. And in here, we'll just add new folders for the tutorials. And under tutorial 1, I have consumption and Fulton Fish files there. Anything else you don't need for the moment. It's just that I like to keep everything in there. So please do that. Know where that folder, this tutorial 1 folder, will be located. Either if you work on desktop, on the documents, downloads, any folder is fine. I would not recommend working on cloud storage though, especially OneDrive. I don't know why. R gets, sometimes it works just fine. Sometimes R gets a little bit moody and uncooperative. So I would recommend not going there, not doing that. Just work on a local storage directory, and then after your work is done, you can upload to the cloud for your records and keep that. So please do that. Have these two files in one folder. It doesn't have to have the same names, just that I would like to keep things tidy here, but it's up to you. And please remember where this folder is. So now jumping to R, actually, just give me a sec. Let me get this. Okay. Now, we are now moving to R. It should be displayed on your computers. So if it's not, please let me know, and I will make sure that you guys have to. But our studio should be displayed on your screens. Please give me an okay if that's what you're seeing, just for peace of mind. All right. So now that we're here on R, like I was mentioning, R has 4 main screens, 4 main panels in the interface that you guys should familiarize with. The one here this one that will be located in the bottom left is what we call the console. This is where R does all the data processing and everything. Is where all the magic happens. So all the codes that you run, all the output that you get will be displayed in this window here. So tables, numbers, regression results, all of that will be displayed here. The top right is the environment and history panel. In here, we will get a list of the objects that we bring into R. So mainly matrices, vectors, variables, functions, and especially data frames. All the data that we import, we put in an object in R called data frame, which works similarly to a spreadsheet in Excel. It's very useful, and it's the benchmark for our work. So all of that should be appearing here. Every time I mention the wording, it should be in your environment, means that it should appear in this area here. The bottom right is also very important, because in here you get an overview of your files. You get plots when you do so. When you produce some plots, they will appear here, and you can have the option to zoom or export as image or PDF. You got a quick list. You got a quick list of the packages that you have installed in your computer. So the main thing is that as R is programmed, it has some functions called utilities that are like in the default version of R, like things like calculating means, standard deviations, plotting, many things are already loaded in R. So even if you don't have, like if you only have the, I think it's called the system library packages, so if you have, I don't know, 2 or 3 which is the most basic things that R has included. Those commands will work just fine. But some people, developers and stuff, they will, or they have worked with a bunch of like very brilliant minds, and when they encounter a problem like an application, think of macroeconometrics in our case, time series work, and they find that the current functions are not enough. They build their own functions, compile in a package, and post it online for all of us to access. So when we when we build on those guys' work, we will bring it here. We can install from this button here. You will type the name. For example, if you're looking for the Lemur package, you'll just type install, and R will do the rest for you, adding a new line here for your package. All of these, again, is all free. You should not have much trouble. And you need to activate the packages. The default packages that R works with are already ticked on my session. They should be in yours. But in case you need any new packages that you just loaded, you just tick. Let's select one at random. It's neater. You just tick, and R is going to let you know, yeah, I have activated this package neater from the library. So R does this because it's keeping its processing memory lean. So not having to go through all these packages saves a lot of processing memory, and that's a valuable asset for our work. We also have a help window here. If you have any problem with any function, for example, plot or so, R will show you a bunch of suggestions of functions that have this similar wording. Once you select the function that you are interested in, it should move to a new window. Here, what is saying? Okay, I have this type of function in all these packages. Which one would you like me to describe? And I think it's desk tools. Let me just give it a second. This one. And it will give you like how the syntaxes of the code works, and what variables should be there, what arguments. So arguments mean options that need to be set to true or false or something like that for it to work, right? It will give you all the tools you need for the code to work. And it's usually like kind of difficult though to find effective help from this help window. So it's always recommended just do a quick Google search. And a lot of people in Stack Overflow or other forums have worked a lot of stuff, and you will very likely find the help that you need for your particular work. And finally, the fourth panel that I would like to mention is this source panel. You can get one by clicking here on this white box with the plus sign to add a new sort of notebook. Usually people work with R scripts or R markdowns. If you're not familiar with R markdowns, it's a way that R will let you like produce your own reports right away without much hassle. Like you do typings, like if you're, I don't know, interpretations, you write your wording, and you can also write the codes and run, and that will add the results. It's very useful, but it's out of scope for our course. So I will not be discussing markdowns. It's something that I would recommend you guys to do on your own time when you're free. But I will, if you decide to add an R script, that will again open up the source window. And in here, you can type pretty much everything in R, and you press enter, and R will not execute anything. It will allow you to catch typos, catch errors before you actually get a bunch of error signs here. Okay, so it's very good for debugging and all of that. I already have one R script ready though, the one that we're gonna use for this session. So you guys should have access to that code. Let me check. So if it's in trouble, let me reload. Yeah, it's there in Culture. So please grab the code and I will show you how to run it as I progress. So the first thing that we're gonna do today, this is not what I want to show, is the first thing that we're gonna do today is learn how to import data. Most of the data comes in a like user-friendly format like CSV or Excel SX, like the Excel files and all of that. But sometimes we come across data that comes in text files. And we also need to learn how to handle that. So we have the consumption.txt file. We have observations for 10 families regarding their consumption and income. So again, having that downloaded, let me show you how to set up your working directory effectively. So many ways we can do this. One way you can do this is by going through files and navigate through your computer. I think the default location for these files here is documents, I believe. But if you like, you can find here, I already have my folder here. You can see it's in my documents folder, so it's easy to access. And when I access the folder, I can click here on this cog and just set as my working directory. And that will effectively make the folder that I desire as my working directory. If you can't do that though, if it's not possible for you to locate your folder and it's getting a little bit mixed. By the way, this is my preferred way to do this, is just to do it manually by clicking session, set working directory, and choose directory, or use the shortcut Ctrl+Shift+H. So when you do that, it will open a pop-up window leading you to find whatever location is your files are. In my case, I have them on documents, tutorial 1, and that's it. So this is the folder I want to work with today. I select it and I click open. And as you can see, the code that are executed is the same with both methods, but I believe the session, set working directory, choose directory is the one that will, like you're less likely to make mistakes and set up your files in weird locations. So do that, make sure to do that. We always do that. If you're already familiar with my tutorials, you have probably heard me say this a ton of times, but it's super important to have that ready. So when you do that, like I mentioned, the files tab here should display pretty much the same as this. Like the same as this. So you can like select and like you have a clear view of your files. Now let me open it not from here, but directly from my documents to show you what the consumption data looks like. When you're working with data that comes in a text document or even in a comma separated files, just make sure that you always do a quick overview of how the data looks like, because the separation between the columns is very important. Okay, so in this case, like most of the times, you will notice that the columns are separated by commas, and you need to be aware of that. Sometimes they're separated by dashes or by dots or something like that. In our case, it's not separated by commas, it's separated by spaces. So we need to tell R to be ready for that. So we're going to use this command in line 3. And we will use that to download. But I see here from the chat, when I click on the consumption file on Blackboard, it opens in the internet browser and I can find how to download the text file. Any suggestions? Yeah, that's actually a very common issue, not to worry. When you go here, you have the text here. Instead of clicking it, just do right click and I think it's save link as, I think. Yeah. And it will open this pop-up window. Make sure it's saved as text document. You save it and you open its that text file ready to go. And let me open it here. Yep, it's there. So yeah, it's a right click, save link as. Alrighty. So yeah, it's not separated by commas or dashes or anything. So we will use, we will have to specify that. So the code that we will use for this, the function is called read.delim. It's used to import, like it's very flexible. It will upload data from a wide range of formats. TXT is included there. You just need to specify if the first row of information, if in the data is true, it's column names. So let me inspect the file again. If the first row of data here corresponds to the column names, in this case, that is correct, right? We don't want this to be stored as observations of individuals. This is the column name, so we can, R can capture that information and give the column names. So that's where we use the header option. And then we need to specify what is the separation. When they're separated by commas, we'll just put a comma here in between the quote marks, or a dot, or the dot is not very likely, but dashes, sometimes that's what they use. In this case, we don't need to put anything, so we'll just leave it as that. A couple of warnings though. R is case sensitive. So if you use like read.delim, it will not work the same as this. So please make sure that you put all in lowercase letters or accordingly, right? Same here, then the file name should be like copied and pasted, should not have like any typos, or it will not work. And like I'm gonna delete this just for a second, and I'll bring it back. And that's all we need to read this table into a format that R can work on. So I will run that. You can either highlight the whole line or just place the cursor in there and click run. It will work either way. Or you can use the keyboard shortcut Control+Enter, this message that is R is showing here. So you see R is reading the data. It's giving these names as the column names. It's not assigning it to any observations, and it's showing me I have 10 observations. This is the consumption values and this is the income values. It's ready. It's there ready for us. But this data is not, like, we can't work with this data in the sense that it's not loaded to our environment. You can see here how my environment is still empty. So in order for R to take this table and reading it and assigning it to an object, we need to use the assignment operator. In this case, is this lower than dash sign, right? So what R is going to take is do this, read this table, and assign that information to an object, to whatever name you want to give it, right? So we'll read the table, we'll take that information, and we'll chug it into this object, which will appear in here, right? So please be mindful of the names that you give to objects. Make sure you don't start with a dot, like dot my data or something like that, because it will not work. Make sure that you don't use spaces like my data. I think it can't start with numbers. Yeah, it can't start with numbers. And if you want to separate, I think dashes will work, but I like to work with underscores, like to separate names. Like if you have, I don't know, names that are too complex or something like that, but something like this, you can like keep it as it is. Yeah, so we run this and you can see here how R is telling me, yep, I have a data frame here called my data, the name that we gave it, and it has 10 observations of 2 variables. So when we visualize, I just clicked in the object here and it's showing me, yeah, this is what we have, rows for individuals and columns for variables, and the column names were captured from the data set. Sorry, I missed a question from Jan in the chat. Sorry, will you upload the solution after this tutorial? Well, Eric will upload the solution guide. The solution guide is a PDF with all the like interpretations and codes. All these codes will be there. And I'm not sure if I am authorized to load my own R script. I mean, I pretty much copied and pasted from Eric's work, but I'll talk to him to see if I can load this file at the end of the tutorial, but I'll have to double check with him because I'm not allowed to provide materials that are not approved by the lecturer. Alrighty, so we have loaded the data, everything it's loaded here, it looks fine. So let's move to question 2, question B. Draw a scatter diagram of consumption against income. So we will see how consumption responds to changes in income. It makes sense. Your income changes, the money that you have available to consumption changes as well, so your consumption habits will change. So we will use the command plot, and the command plot, let me just show you something. When you start typing the plot, you'll notice that R will show you a little pop-up message here telling you, so please put the variable in the horizontal axis first, so the independent variable, and put the dependent variable second. And then these 3 dots mean that we have more options to customize our code. Okay, so the first thing that we need to do is to put the variable in the horizontal axis, then the variable in the vertical axis. Okay, there is one problem though, but these names of the variables, even if they are how these columns are called, R will not recognize them because they are not part of the environment So you can either attach the data set my data, right? And then you can work with the columns in the data frame as if they were independent variables, because I will go and read into all the data frames and try to find columns that have these names. I will not, I mean, I don't like to work with this in the sense that sometimes I work with data sets that have kind of similar names or even the same name. So if I had another data set here that also has a column called ink, then R would be a little bit weird, right? You can just do that, and then you don't need to worry about specifying where these columns will be taken. If you don't attach it, then you need to specify where this column is. So that's why we use the $sign. The $sign is the way that R says, okay, I need to find a column with this name contained in data frame with this name. So I will go to my data and it will find a column called INC and it will work with that information. Okay. So let me just not fix, but rearrange this code just a second, just to show you what I did there, because I understand that it might look kind of weird with the spaces and everything. So what I did with this layout of code is that when you start typing and you put everything in the same line, sometimes you have the nuisance of having to scroll here and here, especially plotting codes can be massive. So in order to keep an orderly view of what you're doing, I ordered. So as you type, every time you put a comma and you press enter, R will put that underneath here, and you can keep pressing enter, and R will like keep that, like keep all the components in between these two brackets that are being highlighted, these two brackets. It's gonna keep them like in the same range, and then you have a nicer view. If you don't want to keep, I'm just pressing Control Z. If you don't want to keep pressing enter, like what I do is that I just keep typing and type and type and type. And then at the end, I just highlight that row of code and go Control Shift A. And R will do the ordering for me. So I'm gonna type that in the chat for you. That's Control plus Shift plus A. And I believe for those of you that are Mac users, I believe that will be Command Shift A, something like that. Make sure you find out which one replaces your Control key in your operating system. But yeah, it's purely aesthetic. It's something I like to see, like code that are like nicely put, but it will work just as fine if you just link a string of code here. And that's it. And I also find this layout easier for debugging and trying to catch typos and everything. So plot, we will select which is our variable in the x-axis, which is the variable in the y-axis. And from this comma onwards, we will select the options. Many options to choose from. You can choose like the size of the points. You can choose the title of the graph. That's what the option main. You can choose the label for the x-axis. You can choose the label of the y-axis. Whatever figurine you want to use as your points in the graph, and you can even choose the color of that, and sizes and bold letters, italics, many ways, many different customization options that you have. So let me open the option for different aesthetics for the plots. The default setting is this white circle, so you will choose the coloring of the silhouette, or you can use like figures that are completely colored like this. So for the first, I would like to just check in terms of the triangles. I want to see triangles in my plot to see what's up. So that's why I choose PCH to be equal to 17. And here, if you want, I don't know, maybe a star or a cross or this other star or this circle, this crossed circle, whatever, you will just you will just change the letter here, the code, the number here. And if you want to change the color, that's what the option call comes into work. Many sources of color in R. I was just doing a quick Google before coming here, and there are a wide variety of colors to choose from. I got this Cadet Blue 4. I think it was from this list, if I remember correctly. Now I don't see it. No, I don't think it's in here, but it's somewhere. So yeah, if you like, I don't know, medium violet red, you can do that as well and change the colorings, or you can find hex codes for codes that for colors that you really like. I don't know if you like this. Let's go for this is kind of purple, I think. So if you like this tone, you just need to grab this code here. I'm copying, and in between these quote marks, just do hash and that, and R will also recognize those colorings. So if you feel creative, if you want to like make your graphs look nice, and you can always do this. So I'm going to run this. If you're going to highlight, please make sure you highlight everything. You don't leave the bracket unselected, or just put your cursor whatever, Control Enter, and it's run. You can see how my graph uses those triangles, and that I think it was like reddish purple color that I selected online. So you can either type the name of a color, like light blue 3, for example, or you can use the hex codes, whatever. So you can make your graph looks nice. Now, moving forward, if you look at the graph, you can probably notice that this point looks kind of weird. Makes little sense that families with an income in between, like something in the area of 120, 130, I don't know, thousand a year or so, are spending over like close to over 900,000 a year. Makes little sense. So this always works out like a reality check. Like you check, okay, this data makes it's kind of weird. So you go and you check your records, and your assistant says, you know what, it wasn't 900, it was 90. So my bad. We need to fix that. So instead of having to go and open your data and fix it and then reload it and everything, like in this case, it's not too much problem because it's just a very small data set. But in data sets that are super massive, finding that annoying point can take you forever. But if you have it located in your R session, what you can do is to find where that problematic point is and just go and replace it. So in our case, it's located in the My Data frame in the 8th row and 1st column. So you can come here, use the index operator, that's the square bracket, and you tell R, okay, please, the item in row 8, column 1, please override it with this number. So when we run this, R is going to go and edit the number for us without much of a problem. You can also, like with these indexes, you can also work like all columns like for example, if you want to edit all columns in row 8 to be equal to not one number, but maybe a series of numbers, you can do that as well. If you want to do all the rows in column 5, you can do that as well. So it's quite flexible, that index operator here. Yeah. Now, if you attached the data, like I showed before, I think, yeah, I did it. It's run here. So I have attached my data. So if I go and run the plot again, you notice that it didn't change, just the color changed, right? Why was this? Because every time you modify the data, you need to detach it. So that's what I'm doing, and attaching it again. And now when I run the command, I will get a graph that is fixed. Okay, so that's why personally, I don't like working with attaching and detaching, because it's a bit weird. Sometimes you spend a couple of hours fixing a problem, and then you produce the plot and changes are not there. So it gets super frustrating. So I would just rather go with the $sign and use that. But, you know, whatever works better for you, we will be there to support you to whatever your decision is. And I decided to change the color so it's easier to visualize the changes that you made in the graph. Now this graph makes more sense, right? As income increases, the consumption for the household increases because they will have more disposable income consuming goods and services, right? So, that's what we know. Actually, no, let's check the next question. The next question is telling us, okay, please compute the mean, median, maximum, and minimum values of these two variables, right? So many ways we can do this. We can, if you have the time, you can actually go and do, hey, mean of income, and then mean of consumption, oops, my bad, and max of income, max consumption, mean, blah, 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 and produce all of those summary statistics. Or you can use just the command summary with the name of the data frame or the name of the column that you are particularly interested in. You can like select all the columns by leaving it like this, or select a particular column using the data, the $, and it will produce these nice summary statistics, like very basic, but at the same time instructive summary statistics for you. So yeah, we have mean values, we have max values, we have median and means. In here, we don't have any we don't have any standard deviations. Sorry, I lost my train of thought for a second there. But again, very basic. Throughout the semester, I think, I'm pretty sure I'm going to show you a couple of other packages that have more complex, more detailed summary statistics commands. The next question, it goes a little bit through what I was mentioning before. Consumption and income, they seem to be highly correlated, right? It seems that they go hand by hand, but we can't put a number in that relationship right away. We can say, yeah, it seems that they're highly correlated, but in order to be to conclude appropriately, you will need to calculate the correlation coefficient, right? So to do that, you can use the command COR, C-O-R, and select. If you want to correlate all the variables in the data set, you just put the name of the data set. If you want to correlate just a couple of variables of interest, in this case, my data inc and my data cons, you can do that as well. You'll get the same result. So let me show you just the difference between using these two commands. If you decide to correlate all the variables in the data set, you will get a matrix, like what we call a correlation matrix, and the values in the diagonals are going to show you, okay, the correlation coefficient between income and consumption, or between consumption and income, it doesn't matter, it's the same number. Or if you're just interested in a particular set of a couple of variables, you will get that correlation coefficient. Just as a refresher, correlation coefficient, you analyze direction and magnitude, if it's positive or negative. So in this case, it's positive. So as one variable increases, the other responds in an increment. And when it's negative, okay, as one variable increases, the other one decreases, right? And with the number, we determine this is a number in between -1 and 1, meaning that any value, for example, in the range of 0 to 0.3 is what we call a very weak correlation. Something like in between 0.3 and 0.5, we call it a weak correlation. Everything, I mean, many different authors have many different approaches regarding this. Everything above 0.7, we consider a very high correlation. So that's the case here. It's almost 1. So they are very closely linked. So that's a way that we can conclude on the relationship between these two variables with more arguments, right, to our favor. So that's always good to look professional in our research. How are you guys traveling so far? Are we doing okay? Do you want me to repeat anything? Maybe check something? Please let me know. Okay, it seems that everything's all right. All righty. Moving on to the next one. Another thing that we will do a lot during this semester is transforming variables, right? We calculate a bunch of logarithms, exponentials, square roots, squares, a lot of stuff. So it's good to know how to do this. So as a practice, we're going to generate 4 new variables. One variable called dcons, which is half of the values of consumption. one variable called lcons, which is the log of consumption in the data frame, one variable called inc2, which is a square of the income of the income values, and one called a square root of income, which is just square root of those values. So we will create these new variables. I'm going to show you two alternative ways to do this. You can either create the variables and add them to the environment as like I like to use the expression independent variables, but not as in the linear regression context, but as in the not contained in the data set kind of context, if you know what I mean. But like adding it outside the data frame is what I mean. Or you can attach it to the data frame. So we're going to do both. What we're going to do is that, remember, we need to do the operation. In the first case, it's just half of consumption, and assign that to whatever name. So in this case, again, you can give any name to this variable. Make sure that it's consistent with the rules that I explained, and that it's new. If the name already exists, for example, if I do this, R is going to overwrite an object called my data to just this string of values. Actually, let me do that just to show you. Yeah, you see how now my data is no longer a data frame, but it's just a variable, a vector with 10 components of numbers. So I have overridden my data, and that's actually a huge no-no. So please don't do that. Let me just reload to make sure that I have everything in there, and just attach it just in case I forget. By the way, sometimes when you attach, you get this warning message. The following objects are masked. It's just telling you, okay, from this object, I identified two variables. That's it. No need to worry about that, even if it's in red letters. So going like this, going like this, what it's going to do is create 4 new variables with the desired operations. I have one called decons, which is half of the values in consumption. I have one called lcons, which is the logarithm of those values. I have one called inc2, which is the squared of the values of income. And I have square root of income, which is the square root of the values in income. And they are here, and they will work just as fine. Like if we want to call them later for a regression or so, they are ready there for you. Or you can choose to add more columns to the data frame. I like to do this because later, if you export the data frame, your data will be already like processed and handled. If you don't, then you have to make sure that your colleagues read through your script and run the codes to get to the state where your data is. So it's the same process pretty much from this point onwards, but remember, if you add the name of a data frame and a $sign, R is going to find an object called this in this data frame, and it's going to say, okay, do I have a column in my data called decons? No, then I'm going to add a new column. So it adds a new column here. If you, for some reason, decide to use a name that it's already in there, R will override it, right? So look at the scale of consumption is 70, 65, 140, whatever. When we run this code, R has, what happened? Sorry. I don't know why. Okay. R has, you see, it was in the order of 90 something, 100 something. It's now what was it? The log of those values. So I have overridden that column instead of adding a new one. So again, let me just reload the data. and run through these codes again. So all those 4 variables will be added to the dataset. Now you can see how I have 6 columns with the new variables. Okay, again, both ways work just fine. Whatever you decide to use is up to you, and thankfully we will be able to give you support if you have any problem. Now we are asked to delete. Whoops, sorry, just 1 second, please. Just plug. Now the next question is asking us to delete the variables decons and square root of income. If we are not using information, instead of cluttering our workspace, it's better just to get rid of it. So in order to do that, we have to deal with both the situations we have. We either created them as independent or external variables, or we have attached them to the data frame. So if they are here as variables in the data frame, in the environment, sorry, we can use the rm function, which stands for remove. And when we run it, we just remove objects with these names. So here you can keep listing objects, and it will delete all the names that you put in between the brackets. Or if you want to delete the columns of a data frame, that's a kind of a complicated process. Many ways to do this, by the way. So if you go online and find a different way and that works for you, it's completely okay. Like I mentioned before, there are many ways, like many people working in R, so new solutions to problems come up all the time. So the option that I selected to share with you guys is the subset function. It will take a data frame and will select a determined amount of columns. So it will go to the data set and it will subtract, hence the minus sign. It will subtract the columns decons and square root of income. Other way, like alternative to this, would be if you want to choose which columns to keep. In that case, you will just change here, and you will like to keep consumption, income squared, and log of consumption, right? So you will choose which columns to keep or which columns to delete, right? And since I am assigning this to the same name, R will overwrite this. So let me run the first option, line 46. You can see it has now 4 variables, which are all of them except for decons and square root of income. Alternatively, let me just reload the data. Oh, sorry. Let me rerun the data. It's loaded there, and I choose which variables to keep. Oh, sorry, I have to add them again. My bad. I have 6 now, so I can choose to keep just these 4, and it will do exactly the same. Consumption, income square, and log consumption will be in this new subset data frame. So many ways to do this. You can choose whenever. I like to use, like when I'm deleting stuff, I like to keep just the codes for delete, for like, yeah, calling for the columns to be deleted, hence the minus sign here. Finally, we are interested in moving into another work, like moving into a different problem. So Eric is asking us to delete everything. Just go to a clean slate and yeah, so good there. And wipe everything. Please keep everything and all this environment wiped. Maybe we can wipe the plots as well. So if you want to keep this code, it will wipe the environment for you. But this code is that it's removing the list of objects in the environment, and this ls bracket means everything, right? So it's removing If you run it, it will wipe everything. Let me just add something to the environment just to have something there. If you want to remove it manually, you just click here in this little broom, and it shows the message clear objects from the workspace. Yeah, you click it. Are you sure? Yes, and it will wipe it as well. If you want to like lose the work that you have been conducting in your console as well, you don't want to see all this output, you just click here on the broom and it will wipe again. And if you don't want to see the plot, click on the broom and you wipe. You see how we have come pretty much back to square zero in terms of work here. All right, that's the way you will wipe everything. All right, that's the end of problem one. Please let me know if you want me to recheck anything with you. Otherwise, we'll keep moving forward. Now, for question two, we are working on a different data set. It's called fultonfish.dat. I hope you didn't have any problems downloading it. Let's just inspect it first real quick. What we do is to go to the folder where it's located, double click on it. If you haven't opened a DAT file before, let me just click here, you'll get something like this. Windows or your like I work with Windows, so my operating system is telling me, hey, I don't have an app or a program to open this sort of files. So please select one and I will try to open using that. I already select Notepad. So that's why when I double click here on Fulton Fish, it will open this in a WordPad window. Jesus. Window. And yeah, so it's allowed me to visualize. From here, you can see that we have 15 columns of data. We have a bunch of numbers. We're not sure which one is which column is which, because we don't have a header, right? From the first column onwards, it's just data. So we don't have a header. We don't have any idea what these columns represent. And we know that they are not separated by commas or slashes or dashes or anything. So we need to prepare accordingly. All right, so it's always good to give it a quick visualization. Just look where you're standing and go from there. Now we have data captured from the Fulton Fish Market in New York City. We use this data set a lot in previous econometric courses. We have information of the sales, the quantity sold of this fish. I believe it's pronounced whiting or whiting, probably, in pounds, and the price that this fish was sold at, right? So we don't know what all the 15 columns know. We just know that the first column represents the date, the second column represents the price, third one represents quantities, and fourth one represents log of quantities. So let's load the data and let's make sure that the first 4 columns have the correct header. So we will use the read.delim command for that. Again, please make sure that you have the right name, that the extension is correct. It's .dat. We need to specify the header. The first row of information is not the column name, so we need to set this to be false. You can use either capital F or, false in capital letters. You'll make sure that the logical condition is met when you get this magenta kind of fuchsia letters here. So it will work either way, if you type false or just equal F. And you will also specify the separation. We don't have commas as the separators, so just leave it empty. So So let's run that and let's see what are loaded. It loaded 111 observations, in this case, days in the, observed in that market, 15 variables. Since we didn't give R any information regarding the names of the variables, it will just give them variable 1, 2, 3, until 50. Okay. So we need to make sure that the first 4 variables represent the correct names. So to do that, we're going to use the call names command. Whenever you use that, and whatever you put in between the brackets will be what you will update the names of the columns. If it's an object that allows column names, it will work just fine. Usually most of the objects will allow that. Let me delete this. I'm deleting that because I want to show you something. So whatever we put in here, R will take this information and will use it on this object. In this case, it's going to take this information and use that as the column names of Fulton Fish. Naturally, you need the objects that you are bringing into, the components that you're bringing into, to be text. So that's why we use the quote marks. We don't type just like a name and then a comma. R needs to know that you're working with text. And since we have more than one component, we need to concatenate those components. So that's why we use the C command here, same as we did before. When we are when we are bringing elements in an argument that only allows one element, we circumvent that by concatenating these 4 components into a single component, and that will be what will upload this. So if we do it like this, if I run this command, please notice that it updated the first 4 columns, but has dropped the names of the other columns. This should not, I mean, this doesn't look like a huge deal, but in case like we ever want to work with, I don't know, variable 14, I think it was this one, it will be a bit complicated to call it. So we don't want to lose even those V5, V6, V7, and all of that. We don't want to lose that. So what we want to do is make sure that only the first 4 components of this data frame are modified. Everything else remains the same. So I will reload it, right? All the V's are back. And I can say, okay, please just keep from component 1 to component 4, hence the colon here. Just do this for component 1 to 4. Or you can do this, I don't know, if you want to edit 5, 6, 7, and 8, you will just start from 5 and finish at 8, right? You don't necessarily have to start from 1. I run it, and now it is showing me, yep, I changed the column names that you wanted. I left everything else untouched. So we're making sure that R works to our favor, not the other way around. Now they are asking us to compute the sample mean and the standard deviation of the quantities sold. So you can use summary actually, but that will not provide us with standard deviation. So I wanted to show you like how to get just those specific points of information, in this case using mean and using SD for standard deviation. You specify which variable you're calculating the mean and which variable you're calculating the standard deviation, which are variables that are contained in the dataset called Fulton Fish. If you attach the dataset, then you don't need to add this bit, right? You can just go like that. Again, freedom of choice there. So I will run these 2 commands in one go. When you do this, please make sure you highlight everything. I want to show you what happens when you don't highlight everything. and you're missing, for example, a bracket like I have here. Look, the first line worked just fine because all the line was highlighted, but the second line, look, I didn't close the bracket, so it's R with this plus sign is waiting for me to bring more information. It's pretty much waiting for me to do this, and it will complete the operation. But if I keep mistakenly running code, like for example, I run the next one, you will notice that, okay, no, that wasn't a good example. Let me go back to the problem that I was having. And then you say, hey, I want to do 6 plus 9. Sorry, 5 plus 9. And R is telling me, hey, that makes no sense. So it will keep waiting for you. And even if you press enter, let me delete this. Even if you press enter in the console, that problem won't go away. R will just keep waiting for you to just give me a bracket, man, and I can finish. So what you need to do, if you encounter these plus signs here, just press escape a couple of times, and that will bring, you make sure that you have this larger than sign there ready for you to work. Okay, by sheer accident, I calculated also the standard deviation. I just wanted to mention that. Now, we are asked to test the null hypothesis that the mean quantity sold is equal to 7,200 pounds a day at the 5% level of significance, and also construct the 95% confidence interval for part C. So I'm going to do these both questions in one line of code. So I will I'll show you how. And since we're doing good with time, let me show you like how to do the hypothesis test line by line. Okay. So we have information regarding the quantities sold in that market, right? We want to explore that if it's likely that the market will sell an average of 7,200 units per day. So the first step that we do in our hypothesis test is define our null hypothesis and our alternative hypothesis, right? That's the first bit. In our case, the null hypothesis will be testing if the true mean of quantities is equal to 7,200. Alternatively, it might be the case that we don't have enough evidence to say that this is true, so we will reject that and take an alternative hypothesis, which is that the mean of quantity is different than 7,200. It's very important to note if your null hypothesis is equal than or larger than or something like that, because the way to calculate it is completely different. Now, the second step that we will do is to state the decision rule. Decision, it's an I here. Decision rule. The decision rule is that we are going to calculate a t statistic, right? And if that t statistic in absolute value is larger than 1.96, which is the critical value at 5% significance, then we will reject the null hypothesis, right? We will reject the null hypothesis. That's our decision rule. The third step is we need to calculate this t statistic. So the way it's calculated for this type of hypothesis test is calculate the sample mean of quantity, subtract this mu that you're testing, then divide that by the standard deviation minus the square root of the number of observations you have. We have all of this information, right? The sample mean is something like 6,336.67, I think it is, minus the mu that we're testing is 7,200. All of these will be divided. This is equal that. All of these will be divided by standard deviation, which is 4,040.12 minus, no, not minus, sorry. All of this is divided by square root of 111. And that in absolute value is equal to 2.26 something, which is larger than 1.96, right? So that will take us to the fourth step, which is the decision. The decision is that we will reject the null hypothesis, right? Finally, for the fifth step, we will be concluding that if we reject the null hypothesis, the statistical conclusion is that we don't have evidence to say that this market will sell an average 7,200 pounds of fish. Okay, I hope that makes sense for you guys. Okay, so step 5 is the conclusion. Just a quick refresher. You probably already remember this, but never hurts to double check old concepts. And the next thing that we can do is create or generate the 95% confidence interval for the mean of quantity. So we can calculate, sample mean plus or minus the critical value, which is 1.96 times standard deviation divided by square root of n, right? And just give a second. We have sample mean in here. We have a critical value as well. We have a standard deviation as well, and we have sample size here as well. And we will get a certain interval of values in which it's 95% likely that the quantities sold are, right? I really hope that makes sense for you guys. If you want me to repeat anything, please let me know so. Now let's do this using R to see how we will save a ton of time instead of having to work through that manually. What I'm gonna do is use the t-test command. The t-test command will ask us to specify a variable, in this case quantities, and specify a value for that mean of this variable to be tested. That's the argument mu. So I'm setting mu to be 7,200. If you don't specify any this, it's equivalent to saying, please test if mu is equal to 0, which is the default setting for this test. But we don't want that. We want a particular value, so that's why we use the argument mu. So when we run this, the output that R is giving us, first of all, is giving you the 95% confidence interval right away. So if we had worked through the formula that I showed you before, we would have gotten that the 95% interval is values that goes from 5,000 as low as 5,574 and as high as 7,094. And also we will calculate the t-statistic. This value in absolute value is higher than 1.96. So we will reject the null hypothesis, and we will accept the alternative hypothesis that the true mean of quantities is different than 7,200. But for the sake of all the tests that we're going to run throughout the semester, I will always bring your attention to the p-value. The p-value here is key. P-value is telling you, hey, how likely it is, like to put it in easier terms, right? The real terms are much more complex, but to keep it in real terms, p-value is telling you how likely is the null hypothesis to be true. Since this value is smaller than the tolerance that we have set, which is 5%, right? 0.05. then we will reject this null hypothesis with a lot of confidence, right? If we had, for example, let me do this for 6,200, which is a value that is in the 95% confidence interval, and you see how we get a higher p-value, which will lead us to the conclusion that we will fail to reject the null hypothesis, right? But this is the result we were looking for. We will reject, and we can also conclude that by checking the 95% confidence interval and noting that 7,200 is not included there. So it's very unlikely that the mean value for quantities is 7,200. Hope that makes sense. Just a quick fresh up of how hypothesis testing works. Now, next thing that we are asked is to produce a plot of log price against log quantities. So we want to check how those two are related. And it's also giving us the condition to change the labels for the variables, for L price changing as log price of wheating per pound, and the label for log quantity as log quantity, that whole text. And then we will comment on the nature between of the relationship between the two variables. So I have prepared the code already. I want to show you something, like to show you how the default, let me attach the data first, how the default setting of Stata regarding the plots look like. You just select a variable for X and a variable for Y and run it. R is going to create this very basic graph with these empty circles that I really don't like. The labels of the axis are just whatever variable name you have. So they're usually not very informative. We don't have any title. It's, I mean, the information is there, but it doesn't look too good. So when we add a title to the table, a label to the x-axis, a label to the y-axis, we change the dot color, and we give it a different color. We create plots that are much more professional, easier to read, right? So in here, again, it's the same information. You can see here when you move from one plot to the other, information is the same, but this one is more informative. You know what you mean by L price as log price of wheating per pound, and what do you mean by L-quan by having the correct label in here. Now, the dots here look quite scattered, right? It seems to have a negative correlation there. It seems that they follow a negative slope, but we're not sure if it's like how flat it is. If it is a little bit steep or flat or something, we're not very sure there. Like by inspectioning with our eyes, it's very difficult to reach a conclusion. So what we do is to calculate the correlation coefficient and, giving it a look. I left this reminder here of how I tidy up the code. Remember when we had the whole line of code and we put everything in order, we just highlight in, I think I can do this with this just to show Control-Shift-A. No, didn't do anything. It's already good to go. But if you had a chunk of code and you want to make it tidy, you can use this shortcut in your keyboard. And so let's see the nature of the relationship. I would like to run this correlation coefficient between log quantities and log price. Actually, we have time. Let me show you what happens if you do the correlation matrix of a data set that is that massive, right? You will get a big matrix. Move this here, and you will have to find where those two variables are crossed. I am correlating log price with log quantities. So I will find log price and log quantities, and this is the correlation coefficient that I'm interested in. But it can be kind of annoying working through this matrix when you only want one value. So the recommended thing is just to ask for the correlation coefficient that you want, log quantities and log price, and you will get that code, that number, same number that we located here, right? So yeah, just so you know how it works when you have a bigger data set. Again, we notice direction and magnitude. The direction is negative, so as quantities, as prices increase, quantities consumed should decrease, right? You will have less money to consume. Hence, the kind of evident downward trend that we see here in the dots. However, since the dots are too scattered, we get a correlation coefficient that is quite low, like it's below 0.3. So as I use that as a rule of thumb. I mentioned, I conclude, yeah, no, this is a very low correlation. So that's the relationship that they share. Now, the final thing that we are asked that that I will show you is how to save the work file to any folder in, this, in the computer. So when you save a work file, it means that R is going to save all the items that you have in your environment. So when you open it again, you don't need to reload the data and transform the data. Your transform data and the created variables, functions, whatever, will be stored here, right? So for that, we will use the save command, and this is just a way to tell R, please capture the whole list in my environment. So that's why it says all equals true, it's saving everything, and it's saving it in a file called tutorial1.rdata. Make sure that the R is in capital letters. And when you run this, actually, let me delete it from my location. When you run this, R is going to create this R workspace file in your working directory. So let me show you what we mean by that. I will just close this and close this. And don't worry about this. This is a code that I have from previous work. I will delete the environment and I will delete this. Let me just come and say, no, don't save. And if I open this work, sorry, not like this. If I open it with our studio, you will notice that it will reload the session as you had it. You see, I didn't upload the data set. It appears there, and it also, your working directory is already fixed, ready to go. So yeah, you can do that if you don't want to like have to regenerate your variables and so on. So it's also one nice tip there for you. Alrighty, so that will bring us to the end of today's tutorial. Thank you so much for your attention, for your attendance. I really appreciate it. I'll hang around for a while until 4 to answer some questions if you have any. Let me just stop the recording.